Okay, so I had a meetup actually a couple of days ago here, and then I talked about new fancy stuff that are coming or about to come, and then I heard that one guy told me that he got kind of almost depressed, we are so far behind and behind the latest and greatest and edge, and I think that there was such a feeling in some other talks. You know, nobody wants to feel that he or she is behind. So I decided to kind of change a bit my talk, and instead of talking about what you should be doing tomorrow and things like that, just to walk you through the history and to speak about the things that most of you are doing today, right? And you're doing Kubernetes, right? Everybody's using Kubernetes. Well, okay, what's wrong with the rest? It's been 5 years, 4 years, right? It's 2019. Wait. Yeah, it's 2019, yeah. Okay, pretend that you're using Kubernetes, and then it will sound okay. So I will explain more or less what we're doing today and how, and more importantly, how we got to do what we're doing today, and a bit of evolution that brought us where we are. Before that, this is how I looked like before. I was younger a bit. I work for a company, CloudBees. We're a company behind a few tools. The one that you most likely know and remember, that's Jenkins. Now, the Jenkins changed drastically. We can talk about that maybe some other time. Anyways, I'm one of the Google developer experts. I'm one of the Docker captains. I work a lot with containers, work a lot with continuous delivery, with Kubernetes. I'm not actually sure what, I change a lot what I do. Anyways, I have a blog like everybody does. I brought some books. Those of you who can expense things should go buy all my books, 5 copies, expense it. That's the best thing you should do. And I have a Twitter account. Okay, so before I move on, I'm just going to execute this command very quickly because it will become relevant a bit later. Okay, cool. Okay, so long time ago, really long time ago, the way how we approach development of applications is that we had those huge applications that could not be scaled. And when I say scaled, I don't mean you have huge application and you can make 2 copies of that application. I mean scale, really scale part of application that is a bottleneck and potentially do it dynamically. We did not do that, most of us. Some of us did, but most of us were building applications that are not scalable, right? Because the needs that we had like 10, 15 years ago were completely different than what we need today, right? Today, even if you build a website about your hobbies, it needs to be scalable. That's how the situation is. But we did not do that. Our applications were huge, not scalable. And in the past, the most common way to find out when something needs to be scaled was when user calls you. This thing does not work, and then you would run around and you would figure out, yes, we had too much traffic, we need to scale, right? Basically, our need for change was based on complaints of other users. And then at one moment, we discovered dashboards, right? Who has dashboards here? Brilliant. Why? So, okay, I'll get back to that. So, we discovered that we can collect some metrics, and we had rooms full of monitors, huge screens, and we would have dashboards, and it was brilliant because we could see a lot of colors and some things going up, some things going down, and there would be usually a red line. And when something reaches a red line, then you press a button and everybody goes into panic mode, and then you try to figure out why something went off the chart, why something reached the threshold, right? That's what we were doing in the past. We are not doing that anymore. You know that stuff. We switched to cloud. We started using some form of scaling groups, and those scaling groups would increase the number of VMs. Remember, that's a long time ago. That's when we were running applications in virtual machines. So auto-scaling groups, or whatever is the name of technology with your hosting provider, would be scaling them up and down, and that was brilliant, right? That's when we stopped using dashboards as a way to discover problems, and scaling was happening just somehow automatically, naturally, but that was extremely slow, and that was using too much resources. And in the meantime, like 4 or 5 years ago, for some of you not yet, you didn't raise your hand, Google afterwards, Kubernetes, it's cool. So we adopted Kubernetes, and Kubernetes changed the game a lot. It's not that Kubernetes did things that were impossible to do today, but it made some things that were very hard for many people happen almost out of the box. And then when you discover the Kubernetes and you start playing with pods and deployments and stateful sets and services and what's or not, then at one moment you most likely come up to the concept of horizontal pod autoscaler, and you would start, and this is still happening in the past, you would start defining, my clicker doesn't work anyways, you would start defining what is the minimum number of replicas, what is the maximum number of replicas, and when it should scale. Like in this case, you see when CPU utilization reaches 80%, it should go up. When it goes below that, it should go down, and so on and so forth, right? And just to show you that that's really not a mystery anymore, if I show you, for example, here, if it works, demos fail. So my application, you need to trust me that before I started this talk, I had one replica of API, now I have two. And it will continue scaling because I set it up to scale on certain thresholds, and those thresholds are reached. And now, while I'm talking, it should continue increasing. Probably soon it will reach 3, 4, 5 replicas. And if the traffic drops, or memory consumption drops, or CPU drops, it would go down, right? That's not a mystery. We are using that for a long time already. Now, the problem with the memory and CPU, as you probably discovered, is that that's really not enough. Because you cannot say memory and CPU is going to be the only criteria I'm going to use when to scale up or scale down. Because not all applications increase memory footprint when they're under heavy traffic, for example, right? Java. Simply some applications use a lot of memory always, and things like that. So that's definitely not enough, but that was a really good push in the right direction. So, but now let me switch to a different problem that historically we were trying to solve in one way or another, and that's if we put applications aside, we can talk about servers, about infrastructure, right? How we were dealing with them in the past. Now, when I started a long time ago, I've been working in the industry for 30 years or something, I don't know how, a long time. And traditionally, like 20 years ago or something like that, in a company I worked for, everybody would over-provision their VMs, meaning that they would ask you, how much memory do you need? And you say, I have no idea, but I'm going to say 2 gigabytes. But you're clever, right? You would not really say 2 gigs, you're going to say 20 just in case. Everybody created VMs just in case, because it's better and easier to ask for more than for ask for what you need, especially considering that you would need to wait for weeks or months until those VMs come to you, right? And some of you banks probably are still doing that, right? You might probably still need, you probably still have situations where the job of getting a VM is 2 minutes, and the period of waiting until those 2 minutes happen is anything between days and months or years. But anyway, that's in the past. We're not doing that anymore. But then we came up with a brilliant idea. We're going to streamline the work. We're going to open a Jira ticket. So you need to open me a Jira ticket, and then you're going to get VMs, right? The waiting time still was months or weeks or years. Nobody knows. And you were still pretending that you need much more than you do, simply because just in case. But that was actually a step backwards, because you had to do, the results were the same, and you had to do the same thing, just you had to open 57 Jira tickets on top of that. But anyways. And still we had those dashboards, right? Still people were watching how our system behaves, pretending that they know what they're doing, and then they would increase maybe the number of your nodes depending on some certain criteria, right? That was still better than opening Jira tickets. And it was really entertaining, you know, going to those rooms and seeing a lot of colors and people so happy because that's at the time, by the way, this was happening when Netflix was not around. So people had no better entertainment than watch dashboards. Anyway, scaling groups still fix this problem somehow. But the problem with all that, with the whole concept of scaling up or down up nodes now, servers, was false in the first place, because you cannot effectively decide when to scale based on criteria like memory or CPU, because what does it mean that you have 25% of memory available? Should you increase the number of nodes? Should you decrease? You don't really know. And then we figured out that there is a better approach. Again, this is now coming back 4 years from now. We're jumping from 10 to 4. We got Kubernetes, and Kubernetes changed those things drastically. Instead of trying to measure and wasting your time trying to figure out where to scale, where to scale down, where to scale up, what it did was actually, let me just run this very quickly. What it did actually is apply the logic that infrastructure should scale not depending on resource usage, but depending on whether somebody needs more. Like, for example, and this is going to happen in a second. You see, for example, I just increased the number of my pods, the number of my replicas, and some of them are in the pending state. So nobody's monitoring memory and CPU. Instead, we are trying to figure out if there is not enough space. I don't care why. We need more servers. We need more capacity. And soon you will see that those few pending, if it happens, at one moment, soon enough, it will figure out that it needs more, and it just created a new server, right? I have no metrics to measure that. All I did, one way or another, is increase the number of replicas. Some of them are in a pending state, and I got my new node. It will go down if the demand drops. It will go up if the demand increases. Nothing more complicated than simply trying to figure out, do I have a capacity for whatever I need right now? Not based on memory, CPU, or anything like that, but simply whether there is something that cannot be scheduled right now. And actually, it increased now to 5 nodes. You can see 5 nodes there. It was 3 before. Anyway, so that was great. But we figured out that that's not enough either, right? Some things need to change on that front. I will go back to that later. But what I want to speak now is how we really monitor things. Anybody familiar with the top command? That was the king of all commands for like 25 years, right? You would sit in front of your laptop or your mainframe or whatever you are. You would have top, and you would be monitoring it. Such a silly time. Anyway, we got Graphite, Nagios, Sensu, and similar tools, and that improved drastically. Anybody using those? You know what they are? Am I speaking Russian? Okay, brilliant. Only 4. That's not brilliant, actually. You're too young, maybe. I don't know. Anyways, the problem with those tools is they're unidimensional, meaning that they provide very limited ways how to discover things. And they're usually binary, like true or false. Do I have enough memory or don't I have enough memory? Is it fast? Is it slow? But very unidimensional. The world changed again since then, and it was very hard to discover your applications, not to speak about the dimensionality of data. We got Prometheus, we got Grafana. I mean, Grafana is a bit older, Grafana is irrelevant, but if you want to look at pretty colors, that's a good one. Prometheus really changed again, one more time, how things work. And it changed because it brought quite a lot of things, like it can discover automatically when you have new applications in your cluster. Instead of raising Jira ticket again, oh, I have a new application, it will just figure it out. It's relatively easy. It's called service discovery. It's figuring out what you have in your cluster, and it's fetching metrics from everywhere as long as there are some metrics. And then we started using, we call it exporters, that would export your memory, CPU, that would export number of requests going through your Nginx proxy, so on and so forth, right? Life was good. And with that, you learn that finally going back to those dashboards, that's also when Netflix became popular, at least in my part of the world, and we stopped watching dashboards, and we turned to Netflix. And I say Netflix simply because it is much more entertaining than watching screen that changes colors. And we got something really cool, and that something cool is called Alert Manager. So instead of me watching screens waiting for something to happen, paying people to watch screens, waiting for something to happen, we would just define alerts. I'm going to show you one simple example. Like right now, you can see that three of my criteria alerts are firing. They're red. They're notifying somebody that there is something wrong in my system. And there are, in this example, 3 of them that are still pending. They will fire after a given period of time. So no more dashboards, at least no more dashboards for getting information if something happens. And instead of that, we are switching to the world where we are notified when there is a problem. So I can sleep at night unless I receive a phone call, which is bad, but it's still better than if I don't sleep at all and watch some monitor. OK, so let me delete my application. No need to continue freaking out about it. What's going on? Why? Where is my terminal? I said, where is my... OK, this is strange things going on here. OK, I don't know. Who can help me fix it? You see? Ah, there we go. There we go. OK, so now the problem with alerts, and I bet that some of you must have experienced it, is that they generate a lot of spam, right? If you're notified whenever there is something wrong in a system and you receive email or Slack or something like that, after 500 email, you're going to ignore it because it does not bring any value for 2 reasons. First reason, because most of alerts are false. They're not really indicating a real problem because you created them badly in the first place. But the more important reason is because we actually do have a lot of problems, but we don't know how to handle them yet, right? And since everybody receives emails, everybody receives notifications, and most people don't give a about it, it ends up being spam. So I'm going to get back to that one as well very soon. But before that, let me start generating some traffic in my application to show you how that really works. I'm going to send 1,000 requests to my application. If Wi-Fi starts working, maybe it won't. We will see. Anyway, I said go. OK, maybe it will, maybe not. Anyway, so going back to now, you discover a problem, you receive spam emails that there is a problem or something like that, and then you're trying to figure out what's happening in production, right? The problem is that most of the time in the past, we were trying to guess what's wrong. And we were guessing what's wrong because of quite a few reasons. First, because our applications are too big. And when something is too big, it's very hard to figure out which part of that something is wrong. The second reason why we had big trouble to figure out when things are going wrong, and this is still not working. OK, this is disappointing. Demos fail. Anyway, the second reason, which I forgot now and I need to remember, I will get back to it. Anyways. And then somebody came, and that really happened to me, to brilliant idea that we can debug our applications, right? So if we don't have no idea what's wrong with our applications, we're going to put debuggers, and debuggers are going to tell us what's going on when something goes wrong. Now, did anybody try to put a debugger to production? What happened? Oh, yeah, slow is very optimistic. Normally, it's crawling. Normally, it's crawling because simply you cannot debug production. That is a fallacy. I would actually go as far as to say that you shouldn't be debugging even application on your laptop because you should be adopting things like something called testing or maybe TDD and stuff like that. You should know what's going on without debugging. But anyways, in production, we don't debug. That was a terrible idea that happened. And then somebody else came to a brilliant idea, is the saying we are going to figure out what's going on through logs, right? Did any of you ever go through logs to try to find out what's wrong? How did that go? Yeah, did you manage to figure it out in a couple of minutes? in my case, it took me more time to read logs than if I took time to read Lord of the Rings, for example, which is quite a big one, or War and Peace, stuff like that. You cannot find out what's going on through logs. And even when you can find out what's going on through logs, what you definitely cannot do under any circumstance to figure out that there is something wrong in the first place. Logs will never tell you that there is something wrong with your application unless you're literally reading one line at a time. Logs might be useful in certain cases at the very end of the process once you figure out that there is something wrong and which part of the system produces the problem and where that problem is. Then when you get to the tiny detail, you can maybe, just maybe, go through logs to try to figure it out. What is much more sensible way to try to find out what's wrong is by reading metrics, right? Metrics are a way how you test your production. You're monitoring your metrics, and depending on the results of those metrics, depending on the outputs and summaries and groupings and averages and what's or not, you're trying to deduce that something is maybe slow, for example. Now, again, the problem with finding out that your application is slow is that that is useless. I mean, it's not useless, it's not very useful. Knowing that my application is slow does not give me a clue what causes the problem. I just know it's slow. So what should I do? Speed it up? Kick it? Doesn't work, right? You need to be able, if you're ever going to be effective with your systems, to be very, very precise. You need to be able to say there is something wrong and the problem is in this function. Between lines 75 and 77 is where the problem is. That's how a serious person would detect and afterwards evaluate the problem, and only then you can go to whomever is working on that application and say there is something wrong, and look, it's there, right? The worst thing you can do if you're somehow in charge of monitoring is to go and call a developer and say your application sucks. That's a bad idea. Your application is slow does not give me any clue about the problem. Saying which part of application is slow, which part of application misbehaves, being able to point to maybe 10 lines and say, I might not be able to say exactly which word is the one that causes this, but here it is, right? And you cannot get that through generic metrics. Memory, CPU, Nginx, what's or not, the duration of a request does not give you that. What gives you that is instrumentation. And sooner or later, you figure it out, and let me open this. And you start writing, I'm going to stop this, and you start writing something like this. A very simple function that says, let me remember what's this. I'm going to record the end and the start and the end time of every request. And I'm going to invoke this function throughout my code so that every single function can record metrics related to it. Once you do that, and I apologize in advance if you're still in Java world and Go does not ring a bell, but that's how more or less you inject metrics into your applications. And only with that, only after you do such type of instrumentation, only when you get that level of granularity of information you're getting without sacrificing performance, you can really, really be able to find the problem, find where the problem is, fix the problem, and all that happening in a matter of minutes, not hours, not days, not weeks, because your users are not going to wait so much and for so long. Anyways, moving forward, while I was talking, I was generating some slow requests, and you can see, for example, where is it? If I send a very simple query and say, give me the number of all the requests that are, let me see, you probably don't see that. Let me increase the size. All the requests that are within 0.1 second duration, divide it with all the requests in total, and you get some useful information. And only with this, now it's something wrong with the screen. Here you go. And you can see that now I can see in this simulation that the problem is in this specific function, right? In this specific request. I don't care about the rest of the application. I only care that that's where the problem is. And you can see actually how my requests while I was talking, because I was generating slow requests, how my response time was dropping. Actually, the percentage of fast requests, and now it's recuperating because I stopped that. But the point I'm trying to make is that with something like this, which are metrics coming from application itself, I can know that actually this is where the problem is. And it's very easy to fix. It's going to take you only a couple of minutes as long as your applications are instrumented. Anyways, now, still, even when you become so specific, even when you know where things are going and what's generating problems, if you continue sending notifications to others, it's going to continue being spam, right? And people are not going to read. And they're not going to read for a simple reason, because 99% of the problems can be fixed without you. Because 99% of the problems are repeatable problems that can be fixed with a simple script. And people start questioning, why am I receiving notification that after I read it, I should deduce that I should restart my application, or I should increase the number of replicas, I should create a node. All those things should not be delivered to you, they're spam, right? Now, I'm going to get back to that in a moment. Let me just turn attention to one more thing, bad thing that we were doing. I'm doing everything live here, just so that nobody gets confused. Okay, so another problem that we were having, and those are the problems with logs. And I still see too many cases where people write logs to files, right? If you're talking about anything but your tiny business with 2 people running, you cannot write logs to files simply because today we're having distributed systems. I cannot go from one server to another to try to figure out where to find information. And I don't even know where my applications are running. I don't care anymore. We are all using clusters. And writing logs to files is just a bad idea. And now, even if you don't think it's a bad idea to write logs to files from human perspective, it is very, very bad idea from performance perspective. Because when you do write to files, do you know what happens to I/O? If you ever wondered why your disk is slow, the first thing you do is stop writing log files, log entries to files. And going back to the human problem, is that I cannot be in 57 different places at the same time. I cannot be, if I have 100 nodes running in my cluster, I cannot be checking files on 100 different nodes. And if you ever come to the idea that you should solve that problem by creating an NFS drive and then store anything there, then you're going to be in even deeper trouble because everything is going to explode. So, what we were supposed to be doing for a long time, but now I think that it's becoming clearer, is that nobody writes to files, everybody outputs to std out. And the reason why we have to output to std out is because we have to send those logs somewhere. And that somewhere can be any place you want. It can be Elasticsearch, it can be Stackdriver, it can be CloudWatch, or anything like that. I'm going to show you, and just how easy it is. I just, maybe, there you go. There's my logging. I just installed it, it's running, everything is centralized. As long as I'm outputting to std out, those logs should be collected fairly easily because the technology already exists. And only when I have something centralized like that, I can start figuring out the details. I can search. I cannot search through files. I cannot search through 57 different locations. Okay, going forward. Okay, so as said before, logging is important because through logging you can find out, do the last mile, maybe, but you cannot prevent problems with your logins, simply because you prevent problems only by predicting when the problem is going to happen, and you can predict if there will be a problem in a future tense is through metrics. So what are we doing today? And those were the things that we were doing yesterday. Today we switched to horizontal pod autoscaler 2. And if you remember from the very beginning, I told you that you can auto-scale your applications easily based on CPU and memory. With HPA2, you can scale based on any criteria you can ever imagine. As long as there is a metric stored somewhere, and that somewhere is most commonly Prometheus, it can be somewhere else, you can configure your applications to scale up, scale down, restart, and do all those things without involving any human being based on any criteria you can ever imagine. This is one example. For example, you remember how I said that it is important to instrument your services? This is a metric that comes from my application. This is not a metric that is generic or anything like that. It comes from my application. And I have here information that if the, let me see, if the response per second is over 50 milliseconds, then scale up or scale down, never have less than 3 replicas, never have more than 10. Very simple rule, and that already removes half of your spam emails. That in itself, I mean, not only that one, but with additional formulas, and stops involving people into those silly processes. Auto-scaling your nodes, I already showed you that that's not even today, that was yesterday. They're scaling relatively easily and fast. Fast depends. If it's on-prem, then it might not be that fast, but still, we are talking about anything between half a minute or 3 minutes to get a new node and continue your life as it was. And we are notifying the system, and that's the important thing with the alerts. Alerts are not being sent to humans anymore, they're sent to the system. System receives those alerts and does something. And not in 100% of the cases, in 99, 98, 97% of the cases, system responds to notifications. And you, dear people, are getting notifications only when the system cannot handle it. It's like, it's equivalent to, well, to us, for example. We are getting impacted by viruses and what's not, our bodies all the time. We auto-repair most of the time. And only when it's really critical, you go to a doctor. You don't go to a doctor every time you cough, right? Or every time you sneeze. That is fixing itself, and that is how we're building systems now. And humans are involved only in special cases. And what that means is that you are too expensive, and your role is to be a designer of the system. You're designing it, and eventually maybe you're reacting only to problems that cannot be fixed in any other circumstance, right? You're on both extremes on the spectrum. Anything between designing a system and responding to absolute tragedies is done by machines, right? At least until AIs don't kick in completely and then kick us all out of this planet and things like that. You're not waiting for Jira tickets. I think that I'm not attacking Jira, just to make it clear, any type of tickets. They're just probably the biggest evil that happened to our industry, because that allows people to hide behind them and wait for something, for somebody else to figure out something. You're not looking at dashboards anymore because they're boring and they're a waste of your talent. And you can tell your boss that I said it's better to watch Netflix during working hours, because the effect of watching Netflix and dashboard is the same, not productive, but one is entertaining. You're not waiting for problems to happen anymore because you're getting notified when the problem happens. You don't wait until it does, until somebody else figures it out. You're really, and only when you build systems like that, you can actually do things that are interesting. Because nobody can convince me that it's interesting to write getter setters. It's not interesting to watch dashboards. It's not interesting to do repetitive things. If you're doing today, not today you're in a conference, but if you're doing one day in the office the same thing as you did the previous day, then your job is boring. And not only that it's boring, but you're too expensive. I can replace you with a script. That's my talk. That's my Twitter. That's my blog. Buy my books, and I have nothing else for you to say except answer your questions. I was faster than I'm supposed to be.
That was real fast, Viktor. Thanks again. I hope everyone is going to be able to take home some of your lessons from here. It was really eye-opening for me, at least. Something like that.
Kidding.
Okay.
Okay.
We have plenty of time to go into the Q&A session. So let's hit up slido.com on your smartphones and upvote the questions and send your own questions to Viktor. So Jeroen asks, what's your advice on avoiding false positives or spamming when you're setting up alerting?
I see it very often, and I don't think it's actually related only with alerting. That happens all the time with testing, for example, as well. I believe that first of all, I believe that we are better off with less than more. My advice is always tests that are failing for no reason other than having a bug should be removed, commented. Same thing with alerts and so on and so forth. Because the worst thing that can happen is for you to ignore a problem. And if 99 problems are not real problems, when the 100th problem comes along, you're going to ignore it. You're going to skip it because it's normal, right? So it's better to have 10 real alerts than 100 alerts that are false positives.
On that note, Tom asks, does it make any sense to get alerts from non-production systems?
What was, say again? What's your advice on autoscaling that one? Does it make sense to get alerts from non-production systems? Yes. Because the logic is simple. I actually don't see the difference. First of all, non-production systems are systems that you're probably using to validate something before it goes to production. So it should behave the same as production. Not maybe in size, not maybe in a number of nodes, but there is no difference in my head except maybe size, as I said before. Second thing is that we are having alerts as a way to find the problems as soon as they happen or even before they happen. And the reason why we want that is two reasons. First, because we don't want angry users, we don't want to lose business, but also because it is much faster and easier to fix things fast, soon, right? If I detect the problem of something that happened now, I'm going to probably fix it relatively fast. If I detect the problem of something that happened last week, then I can just go home and if you're religious, you can pray to God, right? So if the logic of having alerts of any kind is to be able to detect a problem so that it's cheaper to fix it, then you want to have it everywhere, absolutely everywhere.
Good point. The next question is, what's your advice on auto-scaling apps that eagerly allocate memory, e.g. JVM apps?
Yeah, don't use JVM apps. There's the advice.
All right, Go asks, do you think that ML will be or is a key approach in handling and finding issues in logs?
Yes. Yes, I think that machine learning is going to be key. Now, I think that we are not there yet, first, as industry. Second, I think that machine learning is too expensive to be introduced until obvious problems are solved, right? So you can have a pretty stable system. Like earlier you were hearing from Justin, 5 nines without machine learning, right? And when you get to those parts that are actually very tricky, then you go to machine learning. But you don't start with that. I don't think it's too expensive, too complicated to start with machine learning just to solve common problems. But yes, in the future, we will have that.
Cool. Next question is, how do you configure auto-scaling to deal with sudden surges of traffic, e.g. Reddit or Twitter hug of death? It seems like I'm old because the phrase I know for this is /dotting.
Yeah, so in many cases, auto-scaling when there is simply not enough capacity, since you get VMs very fast, it's half a minute, works. Now, if you need really something more complex and to avoid those problems, then you can still employ metrics. And depending on metrics, whatever those metrics are, auto-scale. It's relatively straightforward, relatively easy.
All right. We still have time for 1 or 2 questions.
Okay.
Any experience with vertical pod autoscaler?
I don't think it works yet.
Thanks, Attila.
We're getting there.
Hope that answers your question, Attila. Let's see. We have still time for 1 or 2 questions. Do you agree that dashboards are for past failures, some sort of tech debt for resilience?
See, which one was it? Oh, the bottom one. Do you agree on the dashboards are for past failures? Okay, some sort of tech debt for resilience. Yes, I mean, you know, simply we are advancing as industry. And it's not that dashboards are bad. They were a good solution 10 years ago. And I still think that there is usage in dashboards. I just don't think that they are as important as they were before. And I don't think that for 2 reasons. First, because most of the cases when we're watching dashboards and our eyes catches a problem, that's a problem that we know in advance that it might happen. And if we know in advance that something might happen, then it's very easy to create alert, right? Now, there is a second usage of, in some people, for dashboards. Okay, so let's create dashboards for things that we don't know that might happen. And now that's a tricky one. It's kind of contradictory. You cannot create dashboards for something you don't know. It needs to happen first, and then you figure it out. Now, when that happens, you're more likely going to dig through data, metrics, for example, and you need to be able to query your data to find out the cause of the problem, if you don't know in advance what's it going to be, right? Now, I'm not saying don't have dashboards. Dashboards are okay, but they are more to visualize. So what is useful for dashboards, say, okay, there is a sudden surge in traffic, I'm notified, all those things, and then you might want to have a holistic view of the whole system, which is hard to get without, and then they're okay. But they have very limited usage in my head.
All right, thank you, Viktor. We've run out of time. Sorry, guys. Viktor Farcic, everyone. And on behalf of the craft organizers, let me present you this small gift.
Let me see how ugly I am. Oh my! That's brilliant.
Do you like it?
I like it. I like it.
Thanks again, Viktor.